So in problems 1 through 3 and 4 through 6, all you really need to know is the definition of a logarithm, which is that if you have an exponent with a base of b and an exponent of x and you get a result, the logarithmic expression of that is log base b of y is equal to x. Problem number 1, we know that 2 is a base, 8 is the result, and 3 is the exponent. So if we're asked to rewrite the equation in exponential form, I can just take my base, which is 2, my exponent, which is 3, and write that as 8. I know that's true because 2 cubed is 8. And that's all those problems are asking you to do. In problems 4 through 6, you're doing the same thing, just the opposite. Instead of rewriting the equation in exponential form, you're rewriting the equation in logarithmic form. So I'm going to do the same thing. I'm going to identify my base, my exponent, and the result. So I can rewrite it by just saying, okay, well, I've got a log with a base of 4 of a result 16 is the exponent, which is 2. Okay, evaluating a logarithm is a little bit different. So let me just do problem number 7 here. So what this is doing is simplify this expression. Well, I know that the output of a logarithm is the exponent that makes the base the number here. So I know that the output is an exponent. So really what this is asking me, if I have a base, what is the exponent of that base so that it's equal to 16? And I know that 2 times 2 is 4, times 2 is 8, times 2 is 16. So I know that that is 2 to the 4th power is 16. So therefore, log base 2 of 16 must be equal to 4. So problem number 12 is asking you to do the same thing as problem number 7. However, the result is a fraction. But I do know that there's some exponent, or there should be some exponent, if it's defined. There should be some exponent so that 2 to that exponent is equal to 1/8. If I had like 2 squared, will that give me a fraction? No. That'll give me like 4. If I had 2 cubed, that gives me 8. So that doesn't work. So Isaac here is saying, isn't it negative? Yeah, it's negative because if I have like 2 to the negative 1, that's just the same as 1/2. If I have 2 to the negative 2, that's 1 over 2 squared, which is 1/4. We can actually just keep working that way and say, well, what's 2 to the negative 3? That's 1 over 2 cubed, which is 1/8. So therefore, I know the exponent that gives me 1/8 is going to be negative 3. So what I would say is that when I simplify or evaluate log base 2 of 1/8, that is equal to negative 3.